Okay, in this video, we're going to take a look at Pascal's Triangle, and we're not going to go into the history of Pascal's Triangle so much, but we're just going to go ahead and start off with some of the neat things about Pascal's Triangle, and we're going to look how to construct it and how to use it for our needs here in Math 3. So one of the first things that we want to go ahead and take a look at when we have this triangle that seems to be this collection of numbers is that if we look straight in like this, okay, those are going to be all natural numbers. So those are going to be our counting numbers. And basically it doesn't, the outside obviously is just going to be a bunch of ones, okay? You guys can see that from there. But on the inside, it starts to go 1, 2, 3, 4, 5, 6, 7, and etc., all the way down. Just kind of like in the second layer, if you will, going diagonally from each side of the triangle. Okay, so another neat fact about this, and that one's pretty straightforward, but this other one's pretty neat as well. This one, if we kind of look at, if you will, the third layer, it kind of has a neat look at this thing, and they are the triangular numbers. And what triangular numbers mean is that if we look over here and we have these dots, we start off with one dot, right? And if we were to add another 2 to that to kind of like stack them up in a triangle, so there's one dot, and there would be 3 dots, so it would balance out. Kind of like you're adding bowling pins, okay? So you're adding 2, right, additional ones. Let me do that in the... So we're adding these 2 additional ones, and that's going to give us a total of 3. And then we go on, and to balance it out, we add 3 more, which is going to intersect right here at 6. Okay, so we're at this guy. And then we go on over to another one if we're going to stack them up. So we're going to add 4 more, which is 6 plus 4 is 10, and so forth, you can see. So that's kind of a neat triangular number there. Neat stuff. And yeah, it's just one of the way, kind of like a consequence of the way that the triangle is built, which we're going to explore later. Let's take a look at another one. Okay, this one is definitely one of the neater, like, whoa, type moments here, is that each row is going to be, if you add up all the digits in the rows here, so that is going to give us the ascending values of 2 to a raised natural number power, okay? So, if we're looking at 2 to the 0 is 1, 2 to the first power we know is 2, which is going to be 1 plus 1. 2 to the second power we know is going to be 4, which could be 1 plus 2 plus 1, and so forth. So kind of continuing that pattern all the way down. So likewise, it says right here we know that 2 to the fourth is going to go ahead and give us 16, and adding all those guys up, we would get 2 to the fourth, or 16. And it follows that pattern all the way down, okay? So, kind of a neat thing. One of the next patterns we're going to take a look at is a little bit more peculiar. Okay, in this part, we're taking a look at the powers of 11, and kind of an interesting note is that when we start off with raising each one of these guys, 11 to the 0, first, second, third, etc., is that it ends up coming out to be exactly that in your calculator. And this whole thing works up into 11 to the 4th, but we got to go ahead and do something different for 11 to the 5th and thereafter. So, for example, I'm going to put 11 to the 5th in my calculator, and I'm going to show you what well, I'm going to write down what the screen shows. Okay, so that's the value for 11 to the 5th power. And so to decipher that, some of the things that we're going to go ahead and we're going to have to carry over some digits is that we're going to go 1 and 1, and then I'm just going to change the color from the 5 and the 5, and usually the first rightmost 3 digits are going to stay the same. We got a 0 and we got a 0. And then to get the next digits, we have to go ahead and add these guys together here. Okay, so that's going to give us that. So the 0 plus 1 is going to give us a 1. Okay, and the 5 plus 1 right here is going to give us that 6. And then at the very end, we just end with the 1, which is right here. Okay, and that will work so long as we don't have any carryover digits. And I don't want to go too far into this because it's more of a curiosity shop than anything. But I could also write down maybe at the end of the video how to go ahead and find the ones that are down here by combining some of the digits. But it does work out. So anyhow, the next part is really going to be where the rubber meets the road and what we're going to be using Pascal's triangle for when we're going to expand some binomials. So let's take a look at that slide. Okay, looks like before we go into the binomial part, we have the hockey stick, which is kind of neat. That basically means is that if you start at a 1 anywhere and then you go diagonal and then at the last minute you veer off, that all of these added up are going to go ahead and equal that guy. And you can test it out however that you wish. Okay, is that, say if I did a hockey stick right here, okay, and let me do that. So this would be my hockey stick, okay, and if you will, right, we add all those up. So we'd have 56 plus 21, that's going to give us 77, and then plus 7 more, 6 and 1, so that is going to be 84. So it all works out. So kind of a neat thing. Again, the peculiarities of the Pascal's triangle are all over the place, and this is just one of them. So now let's take a look at that binomial expansion part. Okay, now these are clearly things that we're a little bit more versed in, especially since we've been studying patterns and whatnot. And what these are going to go ahead and help us to do, the Pascal's triangle, is that, you know, when we start expanding out all these binomials, we know that this guy right here obviously is going to equal 1, and something a plus b to the first power is just going to equal a plus b. But we know that once we start getting into these things being multiplied out, and then doing this one 3 times, and then doing this one 4 times, foiling it 4 times, and foiling this one 5 times, you go ahead and you start to go, oh man, I need a pattern to get this thing done, because I'm going to be here forever if I just do it real, you know, just basically do it all out by hand. What's a better way to do it? And so what we're going to do is that in the next section, we're going to take a look at all of what these binomial coefficients are going to be. Oops, I'm going to do them in a different color here so we can cross-reference. There's a 1 and a 1. And how are we going to use those to be successful in saving time to expand these binomials out so I don't have to do all this amount of crazy foiling over and over again. Okay, so we're going to take that pattern and take a look at, just in general, this pattern as well as the binomial triangle, if you will, starts to go ahead and expand its way out. And so, yeah, and then we're going to come up with a way to do larger expansions in a way that we understand. So, let's go ahead, and now that we've kind of like introduced Pascal's triangle and some of the neat things about it, let's find out how to build one. So here we go. Okay, so here's Pascal's triangle, which is incomplete. So for a moment, even if you want to pause the video for a moment and just see if you can look at what are some of the patterns that we could go ahead to fill in some of those hexes that are blank, okay, and keep that pattern going. And then I'm going to show you the way that in which most students process it out and that are able to build this. So go ahead, take a look at it, pause the video, and then see if you're correct. Okay, so one of the things that we want to go ahead and do when we're building Pascal's triangle is that we always start off with these 1s on the side. Okay, so the 1s go straight down. Now, with the 1s, what we do is that if I were to look at how do I get the other numbers that are inside the triangle, if you will. So basically what we do is that we have these two together. We're going to add 1 and 1 and give us a 2. We're going to add 1 and 2 to give us a 3. We're going to go ahead and this next 3, add 2 and 1 and give us a 3. Add 3 and 1, 4. And you can see as we bring this down, we could start filling in the pieces in which we don't know. This is going to give me a 4. This right here, 5. This is going to give me a 10. This guy right here is going to give me a 5. And go ahead and challenge yourself to fill out the rest of Pascal's Triangle. I'll give you a moment, and just using that pattern, and then compare your solutions with mine. Okay, so there we go. Hopefully that the ones in the red are much like the ones that you gave a try to. And so let's go ahead and take a look at how am I going to use Pascal's Triangle and some patterns to expand some binomials. Okay, so I put the Pascal's Triangle that we knocked out on the last page over here to the right, and let's look at some patterns, okay? And I want to, just look at the patterns between this, set of data as we go down and the actual triangle itself. And here's some of the things that I want you to keep in mind. Okay, so 3 things to keep in mind. First, how does the exponent of the binomial relate to its expansion? Let's take a look at that first. This binomial, this is 0, and then we have 1 term. This binomial is raised to the first power, and we have 2 terms. Raised to the second power, 3 terms. Raised to the third power, 4 terms, and so forth. So, how does it relate? Go ahead and think about it for a moment. Okay, a sample answer would be, is that, how does it going to go ahead and relate? Is that there is one, or I should say, there is the exponent plus 1 number of terms in the expansion. Okay, so that's important to know. So how many terms, expand, I'm spelling stuff wrong all over the place here. Okay, so let's go ahead and take a look at the next one. How does the exponent of the binomial relate to the triangle? Okay, so if we look, we are looking at what does this correlate as far as these numbers, and I'm going to put some numbers in front of here, like 1 and 1, some coefficients. Okay, that perhaps we kind of like just, we don't put there for obviously quality of life reasons, but let's take a look. Is that the 0 exponent has a 1, and then we have a 1 here. Okay, notice that that is going to be the first row. Likewise, if we go ahead and put, this is 1, this has 1 and 1 right here, 1 and 1, and this is going to be, of course, the second row. Going forward, if I have this 2 right here, and I have 1, 2, 1, that's going to go 1, 2, 1, and that's going to be the third row. Okay, and then of course one more for just good measure. 3, we got a 1, 3, 3, 1, 1, 3, 3, 1, and that's going to be the trying to get this fourth row. So how does the exponent of the binomial relate to the triangle, and what row of the triangle that we want to use? A good sample answer would be something of this sort, is that we would use the exponent plus 1 row to find the coefficients. Okay, so that means is that we know how many terms now are going to be in our binomial expansion, and then we know which row to use to find the coefficients of all of our terms that are going to be counted up. Now, finally, okay, so the patterns for A's and B's, what I'm going to do is that these, we're just going to kind of leave as is and say like, okay, anything raised to the 0 is going to give me 1, and anything raised to the first power is just going to give me what it is. The patterns really kick into gear when we start doing this, okay? So what I'm going to do is that I'm going to take a look at the A's first. A to the second plus, and then we have an A right here to the first, and then plus like an A to the 0. Okay? And likewise, we could think about the B's as we start on this end going B to the second, and then moving in this direction, B to the first, and then B to the 0. And so if we look at the way that these evolve, okay, is that we start off with this A, and it's going to be raised to this, and then we take it and we move the exponents down 1 each time till we get to 0. And likewise, we can start over here with this B and then raise it to the second power, which is going to be right here, and move it this way, okay, down 1 until we get to 0. So you can do that with any of these, working them out. So let's just take a look at the third one. And we're not going to do too many of these because I know that they're a lot of work, okay? So we start off with A to the third, and we went from A to the third, to the second, to the first, and then an A to the 0, which again just kind of goes away because it's raised to 0, it's 1. And then we have B to the third, so we go B to the third, B to the second, subtracting, B to the first, and then B to the 0 power, which is just going, that's why it's not there. It's basically just a 1. So that said, is that what we're going to do is that we're going to combine these 3 observations using the number of terms, the coefficients from the Pascal's triangle, and then the exponents in the expansion itself, to go ahead and expand some of these problems in the next videos here. Okay, so yeah, let's put all these skills together, and I'll see you in the practice area. Okay, now that we have kind of discovered some of the properties of this Pascal's triangle, let's use it to do what is intended for here in Math 3. Okay, so what we're going to do is that we're going to expand this binomial. So the first thing that we want to do is that we want to run through all these properties in which we've, again, discovered in the past parts of the video. So the first thing that we want to do is that we want to go ahead and say, like, how many terms is this thing going to go ahead and have when I expand it all out? So I know I take the 4, I add 1, and so it's going to have 5 terms. Okay. So which row do I use in Pascal's triangle? We know that we take the exponent and we add 1 to it, and that is going to be the 5th row. Okay. So the 5th row, that basically means 1, 2, 3, 4, 5. We take the 5th row, and we know that we are going to use this as the coefficients of our A's and B's. Okay. So what we want to do is this is the way that I set it up, is that I make 5 the number of terms. I make space for each one. So it's 2, 3, 4, and then 5. Okay. And what I'm going to do is that we make sure this is for the terms that we just again determine that we're going to have when this thing's all expanded out. So we got 1, 2, 3, 4, 5. Okay. So just to make sure that you know why we have it, that's the 5 terms. Okay. So there's 5 spaces. And the 5th row, what we're going to do is that we're going to take all the numbers going from left to right. 1, 4, 6, 4, and 1, and put those in there first. Then what I like to do is that I start off with A, and we know that when I'm talking about A, we're talking about this exercise that we did last video with all these guys right here. So we're going to start with A to the 4th. So I go A to the 4th. And then I just count down A to the 3rd, A to the 2nd, A to the 1st, and A to the 0. And then what I want to do is that I want to go in the other direction with the B's. B to the same power right here, 4th, B to the 3rd, B to the 2nd, B to the 1st, and B to the 0. And now what we're going to do is that we are going to find out what A and B are. Okay, so let's take a look. If I were to put the template of A plus B right here, what we want to do is that to determine what A and B are going to be, the numerical or the variable replacement, is that A is going to be, every A is going to turn into a 2x, and B, this is important, B is going to be the number in back, or could be a variable in back, including its sign. Since it's positive, we don't need to go ahead and keep it as a plus 3. We could just say 3. However, if this right here were a negative, we'd have to put a negative 3 down there. And so what we want to do is that we want to turn all these A's and B's into, or A in the 2x and B in the 3. So let me go ahead and do that. Okay, so you can see that I've just extended the black lines down, and then I just dropped in. If you look straight down each one of these, the A's turn into the 2x's, okay? And making sure that I put the parentheses around them, okay? So the parentheses right here on each one of those are very important because both of those are being raised to that exponential power. And likewise, I turned all the B's into just a 3 down each one of these guys. And now we're just going to clean things up. Remember, when we clean things up, and I'm going to do out each one of these separately here, is that when we clean things up, we have to remember the rules of exponents, okay? So this first term right here, starting in the first space, we just have 1 times, and this is going to go into each one of those. Let's see, 2 to the 4th power is going to give me 16, and x to the 4th power, and then 3 to the 0s is going to give me 1. Then I got 4 times, let's see, 2 to the 3rd power, which is 8, and x to the 3rd times the 3. And likewise, I'm just going to go right up the entire, simplifying out all the exponents doing this nice and slowly so we don't make any mistakes, or if we do, we're showing all our work so we know where to find them, okay? So now the only thing I need to do is multiply the rest of these out, and I'm just going to write them down below, multiplied out. Okay, so basically the only thing I did is that I multiply all the coefficients and just constants together. And notice that these are all positive. And so what we're going to do is that we're just going to put plus signs in between each one of those, and that's that, okay? So that is basically, and just to show what we did, I'm going to erase this part over here, is that we took this guy right here and we expanded it out. Now, it seems like that's a lot of trouble, but it is, at least in my opinion, better than having to do this, especially if you ever multiplied, you know, you're doing foil and then you have to do extended foil and all that other stuff. It ends up being kind of a mess. That's a lot of work. But these all mean the same thing, okay? So what we're doing is that we're using Pascal's Triangle to create kind of a shortcut for expanding out the binomials, all right? So let's go ahead and take a look at another one that has negative signs in there, and see if we can put the pieces together for that. So I'll see you in the next example. Okay, let's take a look at how to navigate our second example here that has two different variables, an x and a y, and this business of a negative sign. So let's go ahead and run through the questions that we want to answer first. The number of terms. We go ahead and we take that and add 1, so we know that we're going to have 4 terms, so 4 sections to fill out. Which row do we use? That's going to be the same as the number of terms if you haven't got that so far. And so we go ahead and we say the 4th row. And so the 4th row, 1, 2, 3, and then 4. That guy right there. Okay, and then we're going to do the ascending orders of A and B and whatnot below, and put all the pieces together. So let's go ahead and get ourselves up get ourselves set up with this business of setting up each section. Okay, so we have the sections there, and now what I'm going to do is that I'm going to put the coefficients in coming from the 4th row, which is going to be 1, 3, 3, and 1, okay? And then I'm going to do the A's, which is going to be A to the, and we always start off with the number here, the exponential number, so that's A to the 3rd, A to the 2nd, A to the, oops, I don't know why I wrote that, A to the 1st, and A to the 0. And then going in the opposite direction, I'm going to do the B's, which is going to go B to the 3rd, B to the 2nd, B to the 1st, and B to the 0. And now what we're going to do is that we're going to find out what A and B are. And again, A is going to be the entire thing that's in front right there, be it positive or negative. It's positive, so I know that A is just going to equal an X, and B this time is going to be equal to a negative 4 y here. And then what we're going to do is that we're going to plug them all in with the parentheses down below. So we need to go ahead and put the B's and the A's into, kind of plug them all in, and then clean them up like we have been, okay? So I'm making a little bit of a mess, but that's okay. All right, so plugging them in, this is what it's going to look like. Okay, so plugged everything in, so I have the parentheses and everything all set up nicely, and so let's start to knock down the pieces. So I got 1 times x to the 3rd times negative 4y to the 0, which is just going to give us a 1. And now I have, in the second part, I got 3, and then I got times x to the 2nd, and then times a negative 4y. Make sure that you put the time sign there because it looks like you'd be subtracting 4y, and you don't want that because that will throw everything off. 3 times x times each one of these squared, so a negative 4 times a negative 4 is going to give us a 16 y squared. Okay, and then finally I got 1 times 4 to the third power, which is negative 4 to the third power, which is going to give us a negative 64. Okay, and times y to the third. So now we're going to have to go ahead and put all the pieces together here and knock these out. So I have x to the third, and then multiplying this all out, I got a negative 12 x to the second times y. Okay, so again, I'm just multiplying these out like we practiced in, all our other classes and whatnot. Now I got 3 times 16 in the next part, so I got the 3 times 16, which is going to give us, 48? Times x and times y to the second. And then multiplying this is pretty easy because it's just a bunch of ones, and there we go. So putting all the pieces together, we got to put the minus signs in there. They got to stay. So the final answer is going to give us x to the third minus 12 x to the second times y plus 48x y to the second and minus 64 y to the third. Okay, so that's what that looks like, expanded all the way out. And yeah, that's how we navigate something that has minus signs and more than one variable. So that's how you do that. And good luck with the other examples, and make sure that you check that you got those correct. And I will see you in the next lesson.